Good morning. Now I will give you the revision on lecture 7, which is about the momentum and also collision. When we talk about momentum in SPM, we have to study that momentum P is mv. Yes, until now it's still correct. And the most important is how do we analyze the equation for this one. And before I move further, I would like to introduce, or I would like to give you some introduction. F delta T equal to mv minus mu. So that means that what is it all about? Basically, this one indicated is impulse, and the impulse is the change in momentum, which is mv minus mu. Initially, it has a speed like this, which is u, and after that, it becomes speed of v and hit something, let's say, or it changes something, and this is the force of impulse and times the time taken equal to the impulse. One of the example is during the collision, let's say a car. This is a car. It hits another car here. Let's say along the highway, car A moves too fast, whereas car B remains stationary. So car A here, initially the speed is 110 km per hour. Once it hit A hit B, the V here, this is VF, becomes 0. Then let's say the A here is 1000 kg. So impulse in this case is I equal to mVF minus mV, which is m0 minus 110 km per hour. Of course, the unit in this case, the unit is km per hour, and you need to convert it to the SI unit. As a result, you can see that it's a very huge impact. On the other hand, we can further that F delta T equal to I equal to this one. So since this is a constant number for the car collision just now, which means that if I am able to increase the time, then the force here become smaller. Hence, why sometimes the car, we must try to design so that it is not very tough or solid. Otherwise, once they hit it, the time reaction time here is very small, then as a result, the force is very large. You can also try to imagine that when somebody want to jump down, maybe due to the fire or something like that, want to jump out for the high building, jump down here. If you put a whatever sofa or cushion here, then because the sofa is not so thick, so that basically it's not so tough or solid, then as a result, the time taken here become very large. It has a buffering time here, and hence if the time taken here is very large, then the F impulse here, it become very small, so they create a better scenario. And right now, I would like to give example on the conservation of momentum, which is in one of your very important part. And basically, conservation of momentum say that PF equal to PI. This one I think most of you know. But somehow, a proper definition for this one is momentum of the system remain constant, or it is conserved if there is no external force applied on it, which means in an isolated system. Okay. For example, if let's say I put the plasticine, I throw it, and it hits the wall, and it remain at that. So theoretically, if we want to use a conservation of momentum, by right, the wall will be moving, but looks like the wall is still remain static. Basically, the reason is the wall is stick to some other wall, which is there is an external force to maintain its position. For this case, we cannot use the conservation of momentum. On the other hand, if let's say I say there's a one block here, there's another block here, hit it, pump. Let's say this is A, this is B, and I say that UA is 3.0 meter per second, whereas UB equal to 0 meter per second. So I say that after that, VA become negative 2.00 meter per second. Then what is VB? This is something you done before also. For the 1D question, 1D question means that only one direction, either left, right, or up, down, something like this. So for this case, you don't need to consider too much, but you just need to know that PF equal to PI, and PF is what? MAVA plus MBVB equal MAUA plus MBUAB. So this case is MA and UA is 3.00. On the other hand, MB, but UB is 0, so I can put it as 0 here. And this is MA minus 2.00 plus MBVB. From that, you can get the VB. And something that I would like to emphasize here is, try to take a look. And here, I put a negative. Why? Of course, initially the question stated that it is negative 2.0, but somehow, for the real case, you must consider that momentum is a vector quantity. So, most of the time we consider that to the right is positive, whereas to the left is negative. And for this case, the final movement of the final movement of the A is to the right, to the left, whereas initial movement of the A is to the right, and you should consider accordingly. So the initial here is 3, which means it's plus 3. On the other hand, here it's minus 2, and you can solve the equation. And when you solve this kind of equation, you need to think about, is there any, is the collision elastic? Is the collision elastic? Basically, no matter what kind of the collision, as long as there's no external force involved, then we can say that momentum is conserved. But even though momentum is conserved, doesn't mean that the KE is conserved also. If we found that the KE is conserved, KE initial step is KE final, then we say that this collision is elastic. And the formula is half mv a square plus half mv b square equal to half maua square plus half mbub square. Again, this is only for 1D analysis, 1D collision, 1D direction. And let me move to the further, which is a 2D. For a 2D, it's still the same thing because it is vector, and you know that for vector we can always resolve it into the particular x and y component. So let's say I give you one example. By right, to make a theta here. This one is a UA, let's say. On the other hand, there's another ball move horizontally, which is UB. In this case, as a result, these two crash each other, collide, and move, let's say, A move at another direction, and he asks what is the final direction and final speed of B. For this case, I repeat again, the A move down with a theta here, and then B move horizontally to the right, and after the collision, object A move as such direction at the speed of VA. So the question is, what is VB? To analyze this kind of question, first resolve it into x and y. So the first thing is to find out the x and y components. And then, of course, you need to use the concept of conservation of momentum. For this case, let us do it one by one. For the x component, PF equal to PI. Bear in mind, if it is a positive or negative, the sign is very important. If it's going to the right, then you need to put it positive. So object A, you can resolve it further into UA cos theta plus UB, same as VA cos theta 2 plus VBX. We maintain the VBX here because later we need to find out what is VBX. On the other hand, we need to move further, which is for the y component. Again, the same thing. For the y component, you can imagine that it's also the same, which is PF equal to PI. And for this case, you see A moving downward that is such a way. So the AY is actually, or VAY is actually a negative value. So it's negative UA sine theta plus 0 because B component has no any vertical, object B has no any vertical velocity. Same as VA sine theta 2, a plus here because it is moving outward, and plus plus VBY. So from this equation and also maybe from some other equation, let's say the information is given, then you can find out what is VBS and then what is VBY. From that, you can count it. At last, same thing. Once you resolve, you find out what is VBX and what is VBY. You can use the Pythagorean theorem to find out what is the total V. So VB is VBX plus VBY square both and set it. And what is the answer? And the direction is theta equal to inverse tangent of VBY over VBX. When you see this video, when we do the division, please try to remember all those concepts. And after that, try to do exercise given in the tutorial. Since every tutorial has about 60 or 70 questions, I believe that it is sufficient enough for you to train yourself. The next is, once you know the 1D and 2D, I believe that most of the time you can solve this kind of the question on the momentum and collision. But if I give you something that is related to the graph, can you solve it? That is something related to your thinking skill. Let's say I give you an example. I tell you that let's say the question states that this is a graph of the P versus X. Let's say. So P versus X. The graph is like this. And maybe here I put it as P0, and here is P1. But P1 is not 0. It just says that P1 is minimum, which is not 0. On the other hand, P0 is maximum, which is also initial momentum. So, in order to analyze this question, the question is very simple. Let's say there is an object, or there is a projectile throw out at the angle of theta here, and you make a projectile motion, which is something like this, and the path is something like this. And then, if you record the momentum of this object over x, this is a displacement x, we get a graph that is similar to this one. So the next question is, what is the theta? This one involves a higher thinking order, higher thinking skill, where you need to understand what is represented by this graph. First, P0 here indicates that it is mv naught. This is v naught. Second, and here, this P1 it indicated the minimum, which means that P1 is P minimum, which is also mv minimum. Then the next question is, what is v minimum? What is v minimum? And for a projectile, you should know that all the time, v is vx squared plus vy squared and to solve it. All the time, okay, for a particular position, at a particular position, the velocity of the projectile is just this one formula. And you need to know that along the path, vx is always constant, whereas vy is not constant. But somehow, and on top, this one we put it maximum height. Maximum height, which means that at the top part here, Vy equals 0. That is a understanding. You must have the skill. You know that Vy equals to 0 when it is at the maximum height. And therefore, since Vy is 0, V is just Vx. If for some other position here, all the time, Vy has a certain value, and Vx is, since Vx is fixed, so which means that the V at some other point here, definitely is greater than V at the maximum point here. So which means that this one indicated it is at maximum height, or else so-called the top position. That's it. And at the top position, you should know that Vx same as the V, same as the V naught x, same as V naught cos theta. So we can further derive it for the momentum. Therefore, Px is P, which is, in this case, I should put it as a P1, in this case, which is P naught x, which is P naught cos theta. And therefore, actually P1 is P naught cos theta. And theta is actually cos inverse P1 over P naught. And let's say if your P1 is given, P naught is given, then you can solve the problem. So basically for this question, answer is very easy, which is only these two equations. It involves these two equations and you can solve the question. But the problem is the understanding. So try to do more tutorial, then you can get more understanding. Thank you.